Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe, and join me on Discord. Let me know what you think about this problem and all these things. Today, just a minor quick update, and I'm still tired. Instead, I ran 8 miles, not much of an update. So I just kind of ran them very fast, so I'm very tired. I've been trying to recovering by just not doing anything when I'm not running, and I'm just eating more of it. Man, I'm still tired. Anyway, let's take a look at today's problem, 1905, count sub-islands. You're given two matrices, grid 1 and grid 2, and containing only zeros and ones. Any cells are considered watered, okay. An island in grid 2 is considered a sub-island if there's an island in grid 1 that contains all the cells that make up this island in grid 2. Return the number of islands in grid 2 that are considered sub-islands, okay. So I think there are about two ways to think about this, right? To break it down, if you will. One is to kind of figure out all the islands in grid 2, and then each of them consider whether they're in grid 1, right? And the other one is, the other way to think about it is just to do them simultaneously in one foot fill, right? So the idea here with islands is you're going to have two strategies, right? Or three strategies with respect to counting or figuring out the connected components. You can use breadth first search, you can use depth first search, or recursively, iteratively stack and queues, or you can do union find, right? Destroy and set union. So any of those things probably will figure out the answer. I don't think it's that bad, right? Yeah. Which one do I want to do? Let's do let's do them simultaneously. Why not, right? So okay, so then maybe now we have something like scene, right? Is equal to force times c, right? So this is going to be if we've already processed in grid 2, right? So then now we just do regular grid-based connected component stuff, which is look at each cell at a time, and if it is not seen, then that means and well, I guess maybe do the other filter first. If it is a 1 and it is not seen, then what do we want to do? Well, we visit it. If I can find it, and we visit it by I don't know. I mean, we can just go, right? So visit get if sub-island ij, then count increment by 1 or something, right? And actually, maybe we don't even need this here. Maybe that's a little bit confusing. Yeah, and then maybe is sub-island, right? And then here we started some xy, right? Yeah, we could use a queue. Why not? Right, and then here we do, we do stuff. We append xy into the thing, right? And then basically there are a couple of ways you can think about this, right? So if at the end, if everything is good, we return true. So there is a little bit nuance here, though. That or maybe return good or something, right? So maybe good is equal to true. The nuance here is that you have to be careful when you do these things simultaneously. And what I mean by that is that if you do early termination, you may run into an issue because you did not process the entire island if you early terminate, right? Like I was tempted a little bit to return early if if there's a 1 in grid 2 but a 0 in grid 1, right? But if you return early, you don't process the rest of the island, and if you don't process the rest of the island, then maybe a future loop will forcefully consider it as part of the island, right? So that's basically the idea. And maybe here, yeah, so that means that this assumes that this is going to be good, right? So then now we go, okay, when we process this, we want to see if grid 1 of it, we know that here everything is going to be let me write okay, everything on Q contains a 1 in grid 2, right? So this is the invariant that we're going to hold or contract that we hold to ourselves. And then now if grid 1 doesn't is equal to 0, is it an integer one or a string one? Because I feel like I messed it up recently. Okay, fine. Then now good is equal to false, because when we process this, grid 1 does not have it, right? So yeah. There is technically, if you want to go by the definition of this problem, there's technically another case where there's like another weird case, but it doesn't actually exist, because basically grid 1's islands have to be a superset of grid 2, right? So yeah. And then now we just do a directions thing going up, down, left, right. So we always set, I always set it up this way anyway. Up, down, left, right. So up is dy, or technically that's down, I suppose. So up is just, it depends how you want to count your ups and downs. But up, left, right, right. And then we could just do it this way. So then, so if it is inbound and it is a 1 and not seen, then we can process this, right? And that's it. I mean, this is a very straightforward breadth first search connected components of just visiting all these nodes one by one. The only thing that's different is that for every node that is in part of this island, we return whether this is good or not. Sorry, there's like a fry going on. That's why I'm like waving. Oh, I thought I clicked on this one. Okay, let's try again. So it looks good. So let's give it a quick submit. Hopefully no silly mistakes. Yeah. What did I do last time? Why is it twice as slow? No, I mean, I did it mostly right, same way. I guess depth first search. I did it last time with depth first search, and it's a little bit different. Yeah, and I guess I did it the same way with, so that I don't worry about early terminating. But yeah, so basically, and what is the complexity here, right? Well, we only look at each cell, surprisingly, even if there are a lot of for loops and while loops, we only look at each cell constant number of times, right? We only look at each cell as the middle one, so twice, and then we look at up, down, left, right, because it's the number of edges going in. So in that case, we only look at each cell constant number of times, and because of we are governed by this scene thing, right? So so yeah, this is going to be all times c, which is going to be linear time, linear space, right? Because remember, linear is in the size of the input, and the size of the input is r times c. Yeah, that's all I have for this one. I think this is regular breadth first search for connected components. You definitely need to know some ways of doing connected components. You probably, I mean, maybe this is too late for me to say it because I already did it one way. But if you know how to do it one way and you're confident about it, try to do it another way. Like if you did it with breadth first search, try to do it with depth first search. Try to do it with union find. But yeah, but overall the idea should be the same, right? It's just implementation, so it's not that big of a deal as long as you're figuring out what your loops are and your invariants are and all these things. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy. Oh, let me show you my code real quick. I mean, I guess I show you the bottom, but phrasing? Anyway, but yeah, the top is this part, which is pretty straightforward, and then this is the bottom. But yeah, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.